Assalamualaikum warahmatullahi wabarakatuh. I'm Teacher Devi. Welcome to my class, GIFs and also GIG students. Suppose you're in the business and you are in the private sector. You own a limited company. All you have to do for your company is maximizing your profit, right? We know that profit is equal to revenue minus cost of production. So you can maximizing your profit and you're minimizing your cost of production. There is a mathematical method to figure of that. It's called linear programming, and it's also we call it optimizing. We can learn further about linear programming, but before then, let's make a dua before study. Rabbi zidni ilma warzuqni fahma. Ya Allah, give me knowledge and good understanding. Amin. Let's go to the class. We're learning about linear program, or sometimes people may call it optimization, because we will know about the optimizing something. In here, if you want to learn about linear program, we have to know the mathematical model. So we have to express the word problem into the mathematical models. Mathematical models is look like this. It's all of this is equation. Okay? And then after this, we have to plot the equation into the graph. So from the graph, we can have a solution region. And then we find the objective function of that graph. And the last one, we can test the point, all the points of that graph for the maximum or minimum result. Okay, now this is a mathematical model. In order to plot the this mathematical problem into the graph, I put this as equation 1 and this one equation 2. Okay, we have to find first equation 1 first. Okay, we have to find intercept. This line intercept with x-axis, for example. So line intercept with x-axis means y equal to 0. If y equal to 0 means x plus 2y equal to 50. So y is 0, x plus 0 equal to 50, and x is 50, and give us the coordinate of 50, 0. Okay, now line intercepts with y-axis give us x equal to 0. Okay, so x plus 2y equal to 50, and the x is 0. Give us 2y equal to 50 and y is 25. The coordinate will be 0, 25. This is the equation 1. How about equation 2? So it's the same thing with in here. So y equal to 0. 2x plus 3y equal to 90, and the y is 0, give us 2x equal to 90, the x is 45. Okay, and the coordinate will be 45, 0. The next one, intercept with y-axis, x equal to 0. Okay, and 2x plus 3y equal to 90, the x is 0, and 3y equal to 90, di is 30. The coordinate will be 0, 30. Okay, after we have all the coordinate here, we have to plot this coordinate into the graph. Okay, from our previous calculation down here, I plot this in here. Okay, this is the equation 1, 2, and also x greater or equal than 0, or y greater or equal than 0, and we have 4 points, right? 50, 0, 0, 25, 45, 0, and also 0, 30. So we plot this into the graph. Okay, this is the y-axis and this is x-axis. So what we have here is 50, 0, 50, 0 here, and 0, 25, 0, 25. Okay. Okay, the next one, 45, 0, and 0, 30. Here you go. This is 2x plus 3y equal to 90, and this is x plus 2y equal to 50. Okay, and then x greater or equal than 0, and then y greater or equal than 0. So we have y is over here, and then the x is over here, right? Okay, now we have 1, 2, 3, 4 points, right? So now we have to get the result region. Okay, result region. We look at this, x plus 2y less or equal than 50 for this equation. So which of the region? The region is over here. But to have a clear region, I will make the opposite one. Okay, I will graph that the solution is over here. Okay, it's actually this region is greater or equal than 50, right? But I prefer to draw like this. So we have a clear region as a solution. Okay, now this one also. This has 2x plus 3y less than or equal than 90. The region is actually over here, but I draw it in opposite. I draw like this. So we have a clear region over here. Okay, it's over here. Okay, and we find 1, 2, 3, 4 points. Okay, this one is 0, 25. No, I just want to put it as A, and this is point B, and this is point C, and this is point D. Now, we have A is 0,25. Okay, B is letter, because this is intersection of these two lines. So C is 45,0 and D is 0,0. How about this point B? As B is intersection of these two lines, so remember that we have a linear equation with two variables, x or y, or in Dignas we known as SPLDV. D because it's two variables. In here we have variable x and variable y. Okay? Now let's find out the point B. X plus 2y equal to 50. 2x plus 3y equal to 90. Okay? We have to times this line into 2. Okay? Now, it becomes 2x plus 4y equal to 100. And then this is 2x plus 3y equal to 90. We use elimination. So we have to eliminate the x. Okay? And this minus 4y minus 3y, y, and then 100 minus 90 is 10. Okay, we put this value into the first equation. So x plus 2 times 0, times 10 equal to 50. And then x equal to 50 minus 20 and give us 30. Now we have a point. So this point B have a coordinate of 30, 10. Okay. From the graph before, we find the point A, B, C, and D. Okay. In the problems, we have optimization or maximization of this. This we call it as objective function. So Z is equal to 50,000 x plus 40,000 y. We put this into this equation. For A, Z equal to 50,000 times 0 plus 40,000 times 25 give us what? This is 0. Okay, we have 1 million, right? We have here it's 1 million, right? This is for A. And B give us Z equal to 50,000 times 30 plus 40,000 times 10. Okay, this give us 1,5 million, and this one we have 400,000. So 1,900,000. Alright, C. Z equal to, I don't have to calculate the Y. So give us 40,000 times 45. And this give us 2,250,000. Okay, and D, since this 0, 0, So this is 0. From this value, 1,000,000, 190,000, and 2,000,000 and 250,000. The one that gives us a maximum value is point C. So the point C is we can get a maximum profit or can get a maximum value of Z if we have a 45 of X and none of the Y. Okay? Okay, let's go to the next example. Example number 2. You are given a graph like this with a solution region in the red one here. And then you also have to find what is the maximum of this function. So you given an objective function of x and y equal to 3x plus 6y. Okay, now we have a point here and here, and we have to determine the equation. First line, the 8 and the 4. Since this intercept with x and intercept also with y, so the equation will be right away we have it 8x plus 4y equal to 32. Okay, I named it as equation 1. And for this, 4x plus 6y equal to 24. Alright? And this is equation 2. And we also right here have the intersection of this line 1 and line 2. It's over here. This one that we have to find because we don't have a coordinate of this point already. Okay? It's actually, you can with your eyeball, you can see that what is the coordinate of this, but it could be not accurate. We have to find it with the mathematical calculation. Okay, now pay attention for these two equations. 8x plus 2 plus 4y equal to 32, 4x plus 6y equal to 24. So we use the elimination method. So we have to eliminate the x, for example. So this one we have to times 1 for this first equation, and then we have to times 2 for the second equation. This will be 4x plus 4y equal to 32. And this one, 8x plus 12y equal to 48. Now, since we have to eliminate x and this one has a positive number and this is a positive number, so we have to eliminate or subtract these two equations. Okay. We have minus 8y, okay, equal to 16, minus 16, and the y is 2. Okay. We put this y equal to 2 into the first equation. Okay, 8x plus 4 times 2 equal to 32, and 8x equal to 32 minus 8, we have 24, and then the x become 3. So we have the coordinate of 3, 2. Okay, you have 3, 2. Okay, you asked to get a maximum value of this objective function. Fxy is 3x plus 6y from this point, and for this solution region. So we have this point, this point, this point, and this point. Okay. Now it's easier for us to make it as a table. This one is 3x plus 6y. So we have what we have here: 0.4, 3.5, 3.2, 4.0, and 0.0. Okay? Okay, now 0.4, I don't have to calculate the x, so I just want to write it as 6 times 4 equal to 24, and this one 3 times 3 plus 6 times 2 give us 9 plus 12 give us 21. And 4,0, I don't have to calculate the y, so 3 times 4 give us 12, and this one 0. So the maximum is 24. So the maximum value of this objective function is 4.0. Okay, thank you. Okay students, that's all for today. That's our linear program lesson. Say hamdalah 3 times. Alhamdulillah, 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 and dua after study. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.